Hello and welcome to today's webinar, Building Predictive Analytics Models, Python versus Minitab. My name is David Peralta, and I am an Area Marketing Manager here at Minitab. A few housekeeping notes before we get started. Since this is a pre-recorded webinar, we will not be having a live Q&A. However, Cody and I will be monitoring questions as they come in and answering as many questions as possible. So please submit any questions you have in the Q&A box throughout this presentation, and we'll do our best to answer them. We also recommend viewing this webinar via laptop or PC for the best results. If you experience a delay or sync issues with the audio and slides, please exit the webinar and rejoin or refresh your page. We will also be sending a copy of the recording following the webinar, so there's no problem if you miss anything or you'd like to review afterward. Now I'd like to introduce our presenter today, Cody Steele. Cody is a senior information developer at Minitab, where he spends his time helping people build the confidence that they need to act on their analytical results. In addition to his work at Minitab, Cody teaches at Penn State University and does consulting projects that have involved everything from characterizing nuclear waste to examining techniques that help student musicians relax before performances. We're super excited to have Cody present today's webinar, and with that, I'll hand it off to Cody to start.
Hey, thanks for that introduction. Welcome everyone. I'm glad that you could join us today for our webinar about some of the differences you would see beginning a predictive analytics effort with Minitab Statistical Software and with Python. Since we're going to make that comparison, there are three components we should introduce: Predictive Analytics, Python, and Minitab Statistical Software. Let's start by thinking about what Predictive Analytics are. You'll get different answers from different people who have different needs. I tend to talk about two characteristics that I think are interesting. One is that when we do predictive analytics, we usually have a lot of data. Traditional regression models are an important tool, but as you get more data, you can do some interesting techniques like CART, TreeNet, random forests, and Mars. The second characteristic is that you want to keep your models updated. It's amazing when you can produce a regression model that describes an unchanging physical relationship and use it. The relationship between force and how far a string is stretched works that way. But when we get into predictive analytics, part of the reason we want to build and compare models quickly is that we think we're going to have to replace those models over time. Then we want to think about what Python is. And when I hear people talk about Python, one of the things that is often mentioned is the community of users. There are just a fantastic number of people using Python to solve problems, and in large measure, they're part of a community that really supports one another. That means that you see a lot of people getting together to use Python, sharing techniques and libraries and code even, when they want to start a predictive analytics effort. Minitab Statistical Software is an all-in-one analysis package that you can use to discover valuable insights from your data. Go back more than 50 years ago now, Barbara Ryan, Minitab's chairwoman and co-founder, with two colleagues, developed Minitab Statistical Software at Penn State University to help students perform statistical calculations easier so they could concentrate more on the applications of their data. I would say that philosophy of making the calculations and techniques easy so that you can concentrate on the insights from your data is still at the heart of what we do today. Part of the way that we help with everything from large-scale digital transformation to eliminating costs from a specific area is by making it easy to get your insights quickly. The comparison that we're going to make today is about starting to do predictive analytics in Minitab Statistical Software and starting to do predictive analytics in Python. We won't have time to do an exhaustive point-by-point comparison. The claim I'm going to make is that it's going to be easier to get started with predictive analytics in Minitab Statistical Software than it is in Python. There are many ways we could look at that. I want to make sure that we understand that Python is an amazing tool that can do anything you can program it to do. To get us going on this conversation, I'm going to describe Python very restrictively from the standpoint of how people introduce predictive analytics with the popular package scikit-learn. Obviously, there are many other packages that will do predictive analytics in Python with different capabilities, but I'd say that looking at scikit-learn is going to be informative about learning to do predictive analytics with Python. And while I'm being a little restrictive about Python, because I'm just using scikit-learn, I'm going to be a bit generous towards Minitab Statistical Software because I'm going to use the Predictive Analytics module. That's going to make a difference in the number of models that I have access to, because one of the features that I think makes predictive analytics easier in Minitab is when you need to make comparisons between different types of models. You will see on the slide there's not nearly as many model types in Minitab, even with the Predictive Analytics module, as there are in scikit-learn. But when you're getting started and want to get a good result quickly, I would say that that is going to be something that you're going to feel all right about. All right, at this point, I think it'll be instructive to build a model with scikit-learn. I'm going to use a data set from Minitab's dataset library to start with. It's heart disease binary data. This is a relatively small data set for the purpose of doing predictive analytics, 303 rows. But it's going to let me illustrate a couple of points about steps where Minitab Statistical Software is going to save you time as you're getting started with predictive analytics. Lots of people are interested in how things like ChatGPT and other AI tools are going to influence doing predictive analytics. So what I've done here is asked ChatGPT to come up with some Python code to build a random forest model. It did that for me. One of the things that Python handles pretty easily is standardizing continuous predictors. The random forest algorithm wants you to do that. And so you'll notice that even in the code that ChatGPT gave me, the Python's already doing that part. It's also put code in there already to split the data into training and test samples so that I get a measure of the model's accuracy that doesn't depend on the data that I use to build the model. But I did run into a problem right away. And so what I would normally do when I have a problem with Python is I Google the answer and I look for something helpful from that great community of Python users. And what I found is something that tells me that I have to go back and fix my predictors so that they don't include any text values. Now, of course, that information there is from Stack Overflow. It could be right, it could be wrong. It might be useful, hopefully. And other people might have brilliant ways of handling text variables in Python. But when you're beginning predictive analytics, I think this idea about you're going to do research to quickly solve the problem and you're going to move on with the first viable solution from a place like Stack Overflow is a pretty common strategy. So when I'm working through the rest of this model, I'm going to treat coding categorical predictors as if it's a step that we have to do to get a random forest model from Python. So I fixed the problem of the text values and the predictors by turning all the categorical variables into 1-0 indicator variables. And if you're getting started with predictive analytics in Python, that's something that you're going to get very familiar with, which makes that our first example of something that Minitab will do for you. We'll look at that in a little bit. Making indicator variables is not a terribly difficult thing to do in Python. And if you decide you're going to use Python for predictive analytics, you'll get that under your belt quickly. But it's something that you don't have to do if you're going to look at Minitab. Fixing that problem in Python is going to reveal another problem, and the way that problem expresses itself is going to depend on how missing values are represented in your data. We already know that text values are a problem, so if missing values are represented by text, such as the asterisk symbol that Minitab uses, or perhaps the word missing, then you'll get a repeat of that error about not being able to convert the text value to a number. Another thing that you could have is simply no value when a measurement is missing. In that case, scikit-learn is actually a little more helpful because it will tell you that the type of model you're building can't accept missing values in the predictors, and it'll tell you which models to consider if you don't want to clean up your data. Scikit-learn, incidentally, is also going to stop and make you clean up your data if the response variable has any missing values. So before you can build your model, you're going to have to make substitutions for your missing value, or the thing advice there from scikit-learn even suggests that maybe you just throw out those rows. And so I reached a simple solution to the missing value problem just for this webinar for the model from scikit-learn by deleting the rows with missing values. That might or might not be the solution that you would choose for your own analysis, but when there are lots of data, it's sometimes a solution that we choose. In a certain sense, the fact that Python forces you to do this could be an advantage. I studied with Dr. Seaver at the University of Tennessee, and he would tell me that a large part of his consulting work was showing people that he'd done the same analysis as many different ways as he could think of. And then he would discuss the composite results. Did you get the same answer different ways? Why did you get the same answer? By doing things different ways. And if you wanted to, you could do that sort of thing with the missing values in predictive analytics. You might decide that for some analyses, you want to substitute the mean for any missing values for continuous predictors. You might decide that you want to discard any rows with missing data. You might decide to impute all of the variables from subsets of other related predictors, and you might find that you do very well if you take the time to consider how you're going to fill in the missing values. But to get a random forest model from scikit-learn, you're going to have to make sure that there are no missing values in your data before you build the model. I want to show here the model building now from Minitab Statistical Software. There is a step that you don't have to do in Python, and that's indicating which predictors are continuous and which predictors are categorical. But part of what you get from that specification is an intelligent default way of handling missing values for this type of model. So in Minitab, I didn't have to go back and learn separate Python coding for what to do with the missing values. In Minitab, I didn't have to go back and learn separate Python code for what to do with the text variables. I don't want to say that you're never going to do data cleaning with Minitab Statistical Software. If you have intelligent values to go back and put where your missing values go, if you know what the real values should be, you're not going to skip that step. But for random forest models, Minitab is replacing missing values for the continuous predictors with the median and replacing missing values for categorical predictors with the mode. Those are fairly standard things to do. There could be times when you want to do something else, but it's a very reasonable way to treat the data, and it has the advantage that you got to build a model without having to learn the additional code and do the additional steps that you had to do in Python. And you can already start to develop insights and make what are probably pretty good predictions without doing anything to the data. It's worth taking a look here at the amount of output that we get for free. To preface that, I should be clear that I didn't spend a lot of time with my ChatGPT prompt, but if I wanted more output from Python, I would have to know more code. In Minitab, if I can enter my variables, then I'm going to get things like the chart that helps me decide if I looked at enough trees in my random forest model. I'm going to get the chart that shows me which variables contribute the most to the model. I'm going to get the chart that shows me that by looking at the 50% of my data with the highest probability of an event, I'm going to capture 80% of the true events in the data. I'm going to get the chart that shows me that if I look at the 20% of my data with the highest probability of an event, I'm going to capture twice as many events as if I took a random sample. If you're just getting started on predictive analytics, you might not even know what sort of visualizations would give you those kinds of insights. Once you knew that's what you wanted, then you would have to try to figure out the Python code, even if that just means trying to find someone who already wrote it. In Minitab, all those visualizations, all the rest of the output is given to you without you having to learn anything, find anything, or write any code. Now, you might want to know if the Minitab model is just as good, and you may have noticed that with the full dataset, Minitab's accuracy falls a little bit short of the accuracy from the Python model. Now, that's not too surprising when you're working with different data sets and different test samples. And I think it's more important to say that I wouldn't consider either of these models to be final without a little bit more investigation. But if you're hung up there, I will go back here and show that if you build the random forest model with Minitab on the same data set where I threw out the missing data and things, then Minitab does a little bit better on its test partition, classifying 91% of the observations correctly. But I don't want you to get hung up on those small differences until we look more thoroughly at deeper settings of a model and feel like we have done the work we need to do to get a good, useful model. That said, the key idea here is that you've gotten to the insights from your data more quickly in Minitab because it took care of some of the common data cleaning without you having to do anything. And you have a model that you can start to learn from in just a few clicks and not a single line of code. Now, I was just talking about making fair comparisons, and I'm sure that there are really fancy ways of doing that in Python. Especially if you've been coding and doing predictive analytics in Python for a decade, you've probably made an investment in figuring all this out, bringing up reports that store things and compare accuracies and make fair comparisons so that you can choose a good model. Each step there involves learning the coding and the arguments for the parameters for a different model type and making refinements and letting them compete against each other. Scikit-learn itself has a whole set of examples that compare models on their website, and that's great. Most of those examples involve choosing the best set of hyperparameters for a single type of model. For example, the best random forest classification model when compared to other hyperparameters for a random forest model. So let's take a quick look at how setting up the analysis to compare different models works in the Predictive Analytics module. The Predictive Analytics module has a section for automated machine learning that has the Discover Best Model analysis. That analysis is going to compare all the predictive analytics models in Minitab Statistical Software for your type of response variable. For a binary response variable, like we've been looking at, that's CART, TreeNet, random forests, and binary logistic regression. So I'm going to return to the original data set here again, and I'm going to show that with Minitab Statistical Software, to compare different model types, we're not going to make any changes in the data to evaluate different types of models. Everything is ready to go without changing up the type of variable or anything to change the representations of your missing values. With a few simple clicks, you've compared the different model types and Minitab has selected one based on the chosen criterion. And it was all just as easy as building a single model type. In this case, we'll see that the TreeNet model performed the best. At that point, we could decide whether to refine that model, to look at that model for insights, or to explore the other model types more deeply. Let's take a quick look here. One of the advantages of being able to explore different model types quickly is to understand the data more deeply. In this data set, we're interested in what predictors are associated with someone having heart disease. In the winning TreeNet model, we can see that thal, major vessels, and chest pain type are the three predictors that are the most important in the model. You'll remember Dr. Seaver's advice to me about solving a problem different ways to see what happens, right? So you could go and do a deeper exploration than I have time for now, but if you produce the best random forest model, you would see that the same three variables are the three most important. And if you produce the results for the best CART model, you'll see again that the same three variables are the three most important. And Minitab made it very easy for you to compare your insights. And that type of confirmatory analysis from different models can help you have confidence in your insights. Looking at these plots, it's neat to sort of realize that the reason you can get an assessment of a variable like thal that's categorical all in one step is because Minitab's already handled that data for you. It didn't get a whole bunch of 0, 1 variables that it didn't know how to connect. It got one categorical variable, and it knows to look at their importance collectively. We've seen here again that Minitab's doing things for you in a consistent way, so that you don't have to learn something new every time you want a new insight about your data. At the bottom of the results for a model is a predict button. I'm going to show that briefly for two reasons. One is that you can see that the operations are as easy as identifying variables. If you could build the original model, you're going to be okay getting the predictions from that model too. There's no more code to learn. There's no extra steps for setting that up. The other is what you see in the second row of the thal column. Even when you don't have all of the information for a new prediction, Minitab will still use the data to produce the best prediction it can without you having to take the time to guess what the value of the missing variable should be. All that analysis in Minitab has been simple so far, but one of the things that we talked about when we were looking at Python was what to do if you got stuck, which basically involves an internet search. On one level, that could be reassuring because Python has such a large community of users who share information online. But what does Minitab do to get you moving again if you get stuck? Well, a couple of things. First, I want to talk about the online self-service option. Look up help for one Python library, and it could be very different in style and quality from another library's help. With Minitab, you get a consistent experience from the professionally crafted support website that Minitab publishes. For example, for every analysis in Minitab Statistical Software, there is an example with the dataset included. You don't have to make anything up. You don't have to find anything. It's there for you to try. Every analysis is also going to include an overview, things to think about for your data, and descriptions of how we do the analysis. But the favorite thing for most people is that you can access the information you're looking for from inside the software. So if you're looking at the TreeNet results and you want more on the partial dependence plots, you come up to the title menu, then you click Help. The target for that first page is the first one where we're explaining the results for the analysis that you just completed. Everything else is accessible from the navigation on the left side, and that's where you find the partial dependence plots. While we're looking at that, I can't help but point out again that because Minitab is automatically handling your categorical variables, you see this comparison of the individual levels right in the results. No programming required. But it's not just the output. If you have settings open for the analysis, like Predict, and you click the Help button, then you go to a page that gives you all the information for right where you are in the software. At the same time, all the other options for the analysis are right here in the side in case you need them. And there is always an example. Now, it might also be that you couldn't find what you wanted fast enough on the website, or maybe you were just hoping not to have to look through web pages to find something out. If you have a license for Minitab, it includes access to professional technical support. You can reach out to them by phone. You could reach out to them by email. You can reach out to them through our online contact form for all your questions like, I thought we paid for the Predictive Analytics module. How come I can't see the menu? Or how do I recode all the missing values in my city variable to Dallas? Or what's the fastest way to see if two variables are the same measurements in different units? You're going to be in very good hands. If you're the type of person who likes to head off problems, you can consider training and education offerings. People who know what they're doing can provide you a solid foundation in predictive analytics using Minitab Statistical Software. If you end up in a situation where you know you need some more advanced work done than you're ready to take on while you're getting your predictive analytics program up and running, then save time and money by letting our statistical consultants help you. They can analyze and interpret your data for you or involve you at every step to develop a data-driven solution together. Whatever level of problem you're having, Minitab has a way to help you move forward. Case in point here, because I can't resist. Some of you might have noticed that it would take a long time to enter your variables if your model has lots and lots of predictors. So if you'd called up our tech support people with a question like, how can I get my predictions faster if I have lots and lots of predictors in my model? Here's what they would tell you. If your new values are in the same worksheet where you built your model, then you don't have to select any variables. The Predictive Analytics module already knows where those columns are. As a matter of fact, when we were using the predictive analytics experience of people like Leo Bryman to build the module, what we found was that many people have their new data at the end of the file where they have the data they used to build the model. So if you happen to have two data sets, you might copy those rows at the bottom of the worksheet where you built your model, click the predict button, and then you're done. There's nothing to do except click OK and look at your predictions where they're stored in the worksheet. Our summary there then is going to be about the ways that Minitab Statistical Software is going to get you to your insights faster. It's taking care of your data for you, so you don't have to do a lot of pre-processing before you can start looking at your results. And it's going to make it easy to do the same things and different things over and over again, because that consistent interface and consistent set of inputs from model type to model type, from analysis to analysis, is going to make it fast for you to get all the insights that you can. I would also be remiss if I didn't point out that you can use Minitab Statistical Software and Python together. That is, there's a Python integration that Minitab has. So if you wanted to do some data cleaning in Python and bring it into Minitab, if you wanted to generate some Python results for models that Minitab didn't do and then bring them in so that they were easy to compare to the models that Minitab did do, you can use these two tools very effectively together by leveraging what each one is good at. I appreciate your attention and time here today. I think the next thing is going to be the QA session, so I'm going to switch control back and see what questions have come in that we can take. And please, if you have more questions, continue to submit them. We'll follow them along as best we can.
Thank you, Cody, for that great presentation. Please submit any questions you'd like answered today in the Q&A box now, and we'll answer as many as possible throughout this webcast. If we can't get to your question during the webcast, we'll also try to do our best and answer your questions via email afterwards. Please also provide your valuable feedback by taking the survey accessible from the pink survey box at the bottom of this window. Now, to close this webinar, I'd like to share some information for those who may not be as familiar with Minitab. For 50 years, Minitab has helped companies spot trends, solve problems, and discover valuable insights in their data. In the webinar today, you learned about Minitab's Predictive Analytics add-on. Some of our other solutions include Minitab Connect, Minitab Engage, Minitab Workspace, Education Hub, Minitab Model Ops, and Real-Time SBC. Thank you all for attending today, and we hope you found this webinar valuable. Take care.